Hello, and welcome to today's webinar on cotton dyeing technologies for a sustainable future, sponsored by Cotton Incorporated and brought to you by Cottonworks. I'm Diana Peck, Marketing Manager at Cotton Incorporated, and we're excited to connect with you today. At Cotton Incorporated, we provide a wide range of information, technical assistance, and innovation to support companies with their cotton business. This includes apparel and home textiles to fiber products in the health and beauty space. As a not-for-profit organization grounded in science and research, our mission is to help companies succeed in their cotton-related business. Through cottonworks.com, we offer a comprehensive resource for cotton information, training, and assistance, all for free. Whether you're looking for detailed resources on cotton or seeking expert guidance, Cottonworks has got you covered. We encourage everyone to register as a user and take full advantage of these resources. Feel free to submit your questions or comments anytime during the session in the Q&A feature. We've allocated time at the end to address as many questions as possible. Additionally, a replay of this webinar will be sent to your email and be available on cottonworks.com. Now, I'm excited to introduce our speakers, Mary Ankeny, Vice President of Product Development and Implementation at Cotton Incorporated, and Buddy Garrett, Associate Director of Textile Chemistry Research at Cotton Incorporated. Mary and Buddy, we're looking forward to your insights, and over to you.
Thanks, Diana. So when a customer is shopping for apparel, there are several key drivers that lead them to their purchase. As we see in this infographic, fit and comfort leads this decision. Price and quality are also lead drivers. This is followed by durability, style, and color. While durability is not necessarily evident when the purchase is made, style and color are obvious to the shopper. Laundering and performance are latent qualities demonstrated after the shopper owns the garment. And the last driver, sustainability, brand, and origin, can also influence the consumer at the point of purchase. The color of the fabric is what first catches a consumer's eye when they enter either a store or scroll through a retail site online. Cotton Incorporated's Lifestyle Monitor survey reflects this, as 88% of those surveyed say they want the color of the garment they receive from their online purchase to match what they saw on the screen. And for the most part, the color does match. This desire for color conformity is also important in denim purchases as well. And although it did not top the list of purchase drivers, sustainability is important to customers. And when asked what sustainability meant to them, customers respond with this set of priorities. So today in this webinar, Buddy and I will focus on addressing how the textile industry can promote and achieve sustainability when preparing and dyeing cotton fibers through the processes we run and the machinery we use.
Okay, good afternoon or good evening, good night, or good morning, depending on what time zone you may be in. I just want to thank you for joining Mary and myself today. Now we're going to highlight sustainable innovations in dyeing. And starting with enzymes, enzymes are specialized stereospecific chemicals that yield excellent results on textile materials. As a rule, enzymes work under mild processing conditions which create less damage to the textile material. So enzymes are normally biodegradable and are more environmentally friendly. As such, they're used more extensively in textile preparation, dyeing, and finishing to replace the harsher chemicals in traditional processes. Hybrids work at wider temperatures and pH ranges with generally less strength loss. One such case is Fiber 52. Fiber 52 is an efficient and sustainable way to prepare, bleach, and dye cotton. The patented process and chemistry use bioactive products instead of the traditional heavy chemistry. It works at much lower temperatures, reducing the time, water, and energy needed. The process works for all shades, from the brightest of whites to dark black. The resulting fabric maintains cotton's natural properties, and it's soft, strong, and breathable. Now, looking at dyes, one major advancement in reactive dye technology has been to put multiple anchor groups in the dye molecule. What this does is improves the chances that the dye molecule will react with the cellulose molecule. The result of these multifunctional dye molecules is that the exhaustion rates are improved, and they can go from 70% up to greater than 85% exhaustion. These dyes are much more efficient, and they allow a greater depth of shade to be achieved with significantly less dye. Less salt is also needed for these dyes, and so the total dissolved solids in the wastewater is significantly reduced. A more efficient dye bath means more reactive dye on the fiber and less dye going down the drain. Now, one example of these high fixation multifunctional reactive dyes are the Avatera SE dyes from Archroma Textile Effects. Avatera SE dyes achieve a fixation rate around 93%, which is leaving only 7% of unfixed dye in the dye bath effluent, as opposed to, say, 40% of the monoreactive dyes. The unfixed dye is easier to remove at lower wash-off temperatures, and it's not bound to the fabric or the fibers in a high salt solution. So compared to conventional dyes, Avatera SE dyes use less water, less energy, and less time. The Avatera SE dye range currently consists of 22 dyes, which provides a wide shade gamut with dyes engineered to provide good fastness properties. Now, another example of the latest technology in multifunctional reactive dyes are the Bizactive 1 dyes from CHT Switzerland. The Bizactive 1 dyes are the latest in a long line of dyeing technology from CHT. These dyes strongly reduce the amount of time, cost, energy, and water needed by dyeing at temperatures from 40 degrees C to 60 degrees C, with fewer rinse baths afterwards. So the increased reactivity and high fixation rates result in high reproducibility. Now, there are currently 17 dyes in the Bizactive 1 range, varying from brilliant yellow to deep black, as you can see here in this slide. As mentioned, the high fixation rates and ease of washing off result in lower soaping temperatures and fewer rinsing baths, conserving water, time, and energy.
The Kadira reactive dye concept from DyeStar considerably reduces water use, waste, and energy consumption by using select Levifix and Remazol dyes with high fixation, yield, and good wash-off properties. The Kadira process uses an optimized dyeing process with improved dye fixation at 50 degrees C, lower liquor ratios of around 5:1, and the soaping agent Cerafast CRD, which allows the use of soap-off rinse baths at 60 degrees C, so you don't have to go up to the boil. The Cerafast CRD is a washing accelerator that's not impaired by electrolyte carried over from the dye bath or impaired by water hardness. So now we're talking about sustainable dye methods. It's also worth noting instances where the dyes themselves have been produced sustainably. And one such example of sustainably produced dyes is the Archroma Earth Colors technology. Earth Colors is Archroma's patented method of creating warm shades from nature. These are biosynthetic dyes, which are derived from natural waste products of the ag and herbal industries. The consumer part of these natural products are still available for their intended purpose, whether it's almonds for food consumption or cotton fiber for textiles. The colors themselves are created in a closed loop process from the non-edible or usable biomass, such as shells of nuts, leaves, or from cotton gin waste. The range of dyes are transformed using anywhere from 70% up to 100% raw materials from natural waste. The Levifix ECO dyes are a new range of reactive dyes based on chemistry which is free of PCA and other regulatory controlled amines. The new dyes have enhanced fastness properties, such as wet fastness and perspiration light fastness, which lead to improved sustainability of the textile end product, especially if you liken durability to sustainability. So for example, the Levifix ECO Black builds well, has enhanced wash fastness, and also has enhanced perspiration light fastness. And the shade range of ECO dyes can be extended by the use of additional existing PCA-free Levifix and Remazol dyes. Now back to our chroma, and our chroma's newest advancement in sulfur dyes is Dyrasol Evolution Black. Traditional sulfur black dye stuff production creates products such as ammonia, sodium salt waste, and a large amount of water is also consumed during the synthesis process when creating a traditional sulfur black dye. So based on cutting-edge synthesis technology developed by our chroma, Dyrasol Evolution Black liquid delivers an overall LCA impact reduction of 57%. And that's taken when measuring its effect on human health, its effect on ecosystems, as well as resource use, compared to a standard sulfur black 1 liquid. And as a dye stuff, when Dyrasol Evolution Black is exposed to chlorine bleach, the Evolution Black sulfur dye fades to a gray tone, as opposed to the brownish goldish tone created by a standard sulfur black shade. And that's illustrated at the bottom right-hand side of the slide. A novel approach to dyeing, Officina 39 has developed their Recycrom dye stuff. This unique dye stuff is made from pre- and post-consumer textile scraps that are transformed through a patented process into a range of pigment powders that can be used to dye cotton as well as other fibers. Recycrom dye stuff can be applied via exhaustion, dip, spray, screen printing, as well as by coating. Officina 39 offers their ready-to-dye collection of 15 dye stuffs, or a brand can collaborate directly with Officina 39 to develop their own Recycrom Pure colors using their own textile waste.
Okay. Zeta Terra is a range of mineral-based pigments created by Zytex, located in Italy, which come in a wide selection of shades. Currently, there are 19 colors ranging from your traditional color you would imagine from minerals to very bright colors. These naturally occurring mineral pigments have very good overall fastness results, better than vegetable dyes, and they're comparable to synthetic dyes. They're highly reproducible. They're applied to cotton substrates at low operating temperatures with a maximum temperature of 50 degrees C. The Zeta Terra dyeing process consumes less energy, and with no electrolytes, the wastewater treatment can be as simple as filtration, just to recover the residual pigment from the effluent. Zeta Terra mineral-based pigments are certified by GOTS and ZDHC. Now, Osatex, which is a company located in Spain, has created this new process that's called Moist, which is a disruptive concept to dyeing. The process is reactive dyeing with 70% less water than a conventional reactive garment dyeing process. In this process, no salt is needed. They do not need electrolytes to force dye stuff from the bath to the fabric because the dye stuff is absorbed by the fabric. This unique disruptive process involves dyeing by absorption, not by exhaustion. Dye stuffs used when dyeing with the Moist process do not need temperature to react with the cellulose fiber, so garments are actually dyed at room temperature. As they don't have hydrolyzed dye stuff, they can do the washing off and soaping at room temperature without water. Most importantly, the Moist process can be dyed in conventional garment dye machinery, so there's no need to purchase any special machinery. Now, we've talked about various dye systems, procedures, processes, and chemistries which provide options for more sustainable methods of dyeing textiles. But how do you know what the impact of dyeing your product has on the environment, and what would be the positive effect of your changes on the conservation and sustainability of natural resources? Well, there are several programs out there that help to measure the impacts of dyes, chemical products, and processes. Now, some examples of the tools available are One-Way from Archroma, EIM from Genealogia, and Elliott from DyeStar. One-Way is a systematic approach to actionable sustainability that provides mills and brands with calculated results that assess the cost, performance, and environmental profile of the evaluated products and processes. All of the dyes and chemicals included in Archroma's One-Way product list have been measured against more than 15 eco standards and criteria such as Bluesign, Ecotex, GOTS, ZHT, etc. Now, as Genealogia so eloquently states, I think on their website, it says, if there is no measurement, there is no improvement. I like that. Genealogia's EIM, or Environmental Impact Measuring Software, is a platform developed to monitor the environmental impact of garment processes. The EIM tool provides reliable measures to help identify where the impact is the greatest and then determines efficient action plans to improve the process. Elliott by DyeStar provides ecological and technical information as well as tools for the optimization of the dyeing process. Positive list of DyeStar dyes and auxiliaries for 18 selected RSLs or eco standards are included within the Elliott software. Now, that's not the only ones. Other dye and chemical manufacturers have similar apps which help the mills to make educated choices about the products and processes they use in order to minimize the effect on the environment.
So chemistry is not the only aspect of textile dyeing that has progressed. As the population becomes more aware of environmental concerns and starts to understand how their actions make an impact, they can begin to think about how they can affect change and work to reduce their water, energy, and chemistry footprint in their community and in the communities they influence. So we just reviewed how chemical companies are achieving more with less and getting creative with materials and technology. So now let's discuss how equipment manufacturers are doing the same. Now, when I first started working in the textile industry almost 30 years ago, a dyeing machine called the Beck or winch was still in use in the US, but it was on its way out. So the winch was a simplified predecessor to today's dye jet. Strands of fabric were threaded through the machine and sewn end to end. The fabric was pulled through the machine by the winch and circulated through a dye bath. These machines could hold multiple strands to dye large lots. In the winch, the liquor ratio, or the ratio of dye bath to fabric, could be anywhere from 20:1 to 40:1. So that means every time you filled the machine throughout the dye and rinse cycle, for every kilogram of fabric you had 20 to 40 liters of dye bath. Garment dyeing relied on the paddle machine. This machine was very gentle to fabrics and is still used today for sweaters and socks, but it also runs a similarly high liquor ratio. So why run so much water? Well, at that time, it was the best technology available, and it is a very gentle operation. The fabric is floating around in water, and there's little to no surface abrasion on the knits. However, using all that water comes at a price, literally. I mean, the more water you have, the more energy you need to heat it. The more water means the more auxiliary chemicals you need, such as salt and alkali. And more water also means more effluent. And that's waste that you need to process. And then there's the cost of the water itself. It just adds up. So, I mean, manufacturers are aware of these costs, and as dyeing technology has advanced, liquor ratios have gone from 20:1 to 15:1 to 10:1, and they continue to fall. Technology continues to evolve. So in this next segment, we'd like to review some examples of modern dyeing technology. So the package dyeing of yarn has also evolved quite a bit since its inception. Since package dyeing is a closed system and uses pumps to force liquor ratio or liquor flow through the packages, It is typically operated at lower liquor ratios than the fabric dyeing machines. So liquor ratios of 10-1 and 8-1 have given way to very low liquor ratios of 3-1 and 4-1 for cotton. The use of air to create pressure inside the dye keyer and pumps that force the dye bath through the packages impart uniform dyeing inside, middle, and outside the packages. Enough water is needed to saturate the package, of course, carry the chemistry through the package, and run the pumps. But some equipment will utilize smart rinsing to enable them to tell when the dye bath is clear and the electrolytes are down and the pH has been lowered enough. And so the more efficiently water is removed from the package, the less time and energy it will thereby take to dry. Moving to jet dyeing technology has also evolved from the days of winches and becks. As I mentioned, winches and becks had liquor ratios anywhere from 20-1 to 40-1. Well, today's high efficiency jets, like the Fong Europe's 10 Airflow, uses air rather than water to move the fabric through the machine. Cotton can be processed at a liquor ratio of 3-1 or 4-1, while synthetics can be run as low as 2-1. And with the fabric in constant motion, the dyeing takes place in the venturi, and there's very little bath needed inside the machine. And because the bath is so low and the machine so efficient, energy savings of up to 40% can be seen. Less water means faster drop fills, and it takes less time to heat the bath, so cycle time savings can also be reduced by about 25%. And using less water means that less auxiliary chemicals such as salt and alkali are needed for dye exhaustion and fixation. Cold pad batch technology has been around for decades, and this is also a low water, low energy dyeing option for both knit and woven fabrics. The fabric is padded through a bath of dye and alkali, run through a pad to remove excess liquor, then wound around a perforated beam. The fabric is covered in plastic, and the beam rotates at room temperature for 16 to 24 hours while the dye reacts with the fabric. Then fabric can be washed either on a beam or preferably on a wash range. No salt or temperature is needed to conduct reactive dyeing on a cold pad batch. It's also possible to desize and bleach via this process. Advances in this technology include things like temperature control of the dye liquor, circulation and metering of the dye liquor, and fabric handling.
Okay, now we're talking about foam dyeing and finishing. Foam application uses air rather than water as the medium to carry chemistry to the fabric. Because of that, water consumption can be reduced to up to 80% versus a conventional pad application. Because you're reducing the wet pickup of the fabric from 100% to, say, 20% or less, the energy and time required to dry the fabric is also reduced. Foam also enables chemistry to be placed on one side of the fabric if desired. For years, foam has been used in finishing applications. However, recent developments with foam have been done in the dyeing arena as well. In fact, quite a bit of research has been happening regarding the foam application of indigo, and it's going to be interesting to watch this technology as it continues to develop. Now, advances in garment dye machinery have also made use of more efficient pumps to circulate the baths, so fabrics are no longer tumbled in machines with high liquor ratios. Mary had mentioned a lot about previous machinery and technology that had high liquor ratios. Well, Tonello has developed a combination of garment handling and control through their garment machines in combination with their core technology to enable liquor ratios as low as 1-1 on cotton. This technology enables the reduction of auxiliaries and effluent as the application level is highly controlled. This machine is versatile, and both a uniform dye appearance as well as novel effects can be created with this nebulization technology. In addition, the core unit can be integrated into any Tonello garment machine. Tonello also has an ozone system, which is called EGO. It's an acronym for Enhanced Garment Ozonation, and is the newest ozone finishing technology under the Tonello brand. O-Free, Eco-Free, and Eco-Free 2 represent Tonello's stages of technical growth in ozone technology. Tonello boasts 3-in-1 ozone, ozone in water, ozone in air, and O-Bleach, which is their patented process that achieves an authentic bleach effect using ozone alone in combination with their core technology that I just spoke about. Now you see on the slide here, the no stone plates. This is no stone is an abrasive drum that creates stone washed effects without pumice stone. It's reusable, it's compatible with Tonello machines, lightweight and easily removable within a few minutes. And you don't have to deal with all the pumice stone dust and effluent and destoning of the garments. Now also, Gina Ligia has technology called ColorBox. The ColorBox technology from Gina Ligia reduces the amount of water needed to garment dye by reducing the space or the gap between the rotating drum and the keyer of the machine. So less space between the drum and the keyer means less water volume that's not in contact with the garments, and therefore less salt and energy are needed to treat and heat the bath. With the patented ColorBox technology, there's less than a 2-centimeter gap between the drum and the keyer, allowing for the lowest possible liquor ratio. In addition, the ColorBox technology controls the rate of acceleration of the drum speed, allowing the drum to accelerate from 0 to 45 RPMs within a few seconds, causing both the garments and the bath to rotate, with the drum drastically reducing the amount of tumbling action that typically contributes to abrasion. So instead of that fabric falling and tumbling hard in the drum, now because that drum speed is faster, you're getting less that tumbling action. The end result is a low liquor ratio dyeing with little to no abrasion. Now also, Gina Ligia's G2 ozone technology, when it's combined with the ColorBox technology, allows you to achieve washdown looks with reactive dyes without excessive abrasion and without harsh chemicals. G2 takes the air out of the atmosphere, extracts the oxygen, and uses it to create ozone gas. The G2 Atmos process controls the humidity and the temperature to create vintage and stone wash effects without using water, stones, and chemicals, with results that are repeatable. Care Applications technology reuses existing machinery by installing customized and unique devices to the mill or laundry's existing machine, which in combination with Care Applications' unique processes provide the controlled application of dyes in a very sustainable manner. Care Applications' EcoFinish technology is a dosing system for the direct application of chemicals and certain dyes on fabrics in the washing machine without a bath. This results in a significant water savings with bath ratios ranging from 1:0.2 to 1:1.5, and a significant reduction in energy consumption. All process steps can be achieved using the EcoFinish process, from preparation all the way through to softening. Dyeing can be accomplished with significant reductions in salt, from 90 to 100% reduction, with fastness results equaling those obtained by a traditional dyeing process. Now, Care Applications also has a system called the close-in system, which is a technology for dyeing cotton using classes that are applied under reduction, such as vat dyes and sulfur dyes. The system encloses the machine without pressure, and nitrogen is introduced for an oxygen-free atmosphere. The close-in technology automatically checks the pH and the redox potential for maximum reproducibility, with a significant savings of alkali and reducing agent.
Once your fabrics have been prepared and dyed using all the latest technologies, it's time to dry them using the most efficient means out there. And that involves using a heat recovery system in conjunction with the tenter frame to collect the warm, moist air expelled from the dryer, remove the heat from the exhaust air, and return the dry, heated air into the range. The heat recovery system reduces the energy of the dryer because it allows for improved air turnover and the heating of already warm air. Some units, such as the Momforts, which is pictured, have automatic cleaning technology built into the exchangers to remove any lint from the exhaust while the unit is still running. And this eliminates downtime and keeps efficiencies up. In addition, new tenter frames have computer-integrated airflow controls to monitor and maximize drying. So in order to be able to realize any kind of improvement in your dyeing process, you must first need to know where you currently are. And to do that, inline monitors are needed on each dye machine. When we were putting together our LCA and collecting data, we discovered that many dye houses do not have the capability to measure the water, energy, and steam use on their individual dye machines. Not only is this monitoring important to understand baseline usage, but it's very helpful for measuring improvements, identifying leaks, and other issues. You can schedule machine use, and you can also control chemical weighing and dosing with these technologies. So all of these contribute to a right first-time dyeing and efficient use of inputs.
Thank you, Mary and Buddy, for that insightful presentation, diving into the dyeing process and equipment. We've got some great questions coming in. If you haven't yet, please be sure to put your questions into the Q&A feature. Now let's move on to some of these questions. And as a reminder, the webinar will be available to watch on Cottonworks, and also we will send you an email with the replay option as well. So the first question we have is, Mary, what are the biggest barriers to the adoption of sustainable dyeing processes in the textile industry?
Well, I think that people are going to say, cost is going to be the biggest barrier. And I feel like you need to really look at the cost. You can't just look at, say, oh, these new dyes, maybe they're more efficient, but they're more expensive. Because when you think about your whole process, can I use less of these dyes? Will these dyes enable me to use less energy? Will they enable me to wash more efficiently and use less water? So you have to have a holistic view of your process. And likewise with newer equipment, once you're able to understand how efficient your dye machine is or your dryer is, and you get baseline understanding of where your costs are, then you may be able to really justify the purchase of a new piece of equipment that is going to be able to save you time, save you water, save energy. And that return on investment could make it very possible for you to upgrade your processes and to enjoy some of these new technologies that are on the market.
Great insight there. Question for you, Buddy. How could someone communicate water and energy savings when the cost of the dye is higher than their current dye?
One way is to use one of the measurement tools that I had mentioned earlier, like One Way by Archroma or Elliott, by DyeStar. These tools or ones like them. They're not the only ones out there, but any tool like that can help by capturing data on your water consumption, the electricity consumption, your steam consumption, all things that you need to use to compare between a traditional process and these and your more sustainable process. It's really difficult to communicate water and energy savings if you're not measuring these metrics. As Mary mentioned, in that last slide, that capturing that and measuring it. Dye and chemical costs are typically the easiest thing to measure in a dye. So that's usually the one thing that a dye house manager is looking at very closely. So when you're trying to balance that increased cost with water and energy savings, it can be difficult to communicate that. So you've got to be able to capture that data and look at it. So, it's a lot of times it's the old saying, what gets measured gets better. So in order to communicate that, you really have to look at that cost savings in some of these things in order to justify a lot of times the cost of that higher price dye.
Great to know. This is for Mary or Buddy. For Zetera, is this used for printing? If so, can it be used for rotary print?
Yes, it can be used for printing. I personally have not done that yet, but yes, the mineral pigments can be used for printing. Question, can it be used for rotary printing? I think so, but I don't know. The best thing to do would be to contact Zytex in Italy. You can look it up on their website. They have some very good technical people that can assist even with how to do that. So, but the short answer is yes.
Great. Over to you, Mary. Regarding jet dyeing, can you explain how the fabric can be dyed if there's virtually no dye bath in the machine?
So, when we talk about dyeing cotton, we talk about dyeing it at 3-to-1 or 4-to-1 liquor ratio. So you just can't dye a 3-to-1 to a 4-to-1 in just any dye machine. I mean, you really need to have a jet dye machine that is set up to be able to run the pumps at these low liquor ratios. And, essentially the dyeing takes place in the venturi. So as long as you have enough dye in the bath to uniformly wet out that fabric, to be able to get your chemistry in solution, run your pumps, then you're able to utilize, say, the lifter reel, or in the case of the 10 airflow, they're able to move the fabric through the machine by air. And as long as you're able to efficiently move that fabric through the venturi during the dye process, then you should be able to dye that fabric just fine.
Great. Another question around foam dyeing technology. So how efficient is foam dyeing technology compared to traditional dyeing in terms of uniformity and depth of shade? And any examples to talk about?
I'm happy to take that one. So with foam dyeing technology, fabric handling is going to be very important. And so make sure that you have, we've done foam dyeing on a lot of woven fabric, because that's in our facility. That's how we have the fabric handled, or we have fabric handling for woven fabric in our foam dye equipment. And one of the in our application, we found it works really well on a variety of shades. And one of the tricks that we use to get a nice uniform dye application is to divide the dye bath over 2 different foam heads, and that enables us to get nice uniformity of the dye onto the fabric. Now, performance of a foam dye fabric is, it performs just as well. We get good penetration into the fabric, and we're able to say if we do a foam dye steam or a foam dye cure, we're able to get excellent dye fixation on that fabric.
Great to know. Buddy, over to you. Are the high fixation dyes more expensive than the traditional reactive dyes?
Yes, in most cases, the initial cost is more expensive because there's a lot of research that went into developing those dyes. A lot of times the chemical companies are trying to, they need to recoup that cost. However, a lot of times you've got to look at it and measure it against the cost savings of what we talked about earlier, where you have water, energy, and time savings that comes about because of the higher efficiency, high fixation dyes. So you're saving money on your rinses. You're saving money on heating up water because you're able to soap off at lower temperatures. And then hopefully what happens is over time, as the volume increases on the sales, then hopefully what happens is they become more competitive with traditional dyes. But you have to look at the whole picture.
For sure. That makes sense. This is a question we've received a couple of times now from the audience for Mary or Buddy. Do you have any comments or insight on waterless dyeing technologies?
Sure. Yeah. Waterless dyeing technologies, this is a new technology that has seen real gains for dyeing synthetic materials. One of the reasons is that it uses supercritical CO2 as the dyeing mechanism, and dispersed dyes are soluble in supercritical CO2. So you can dye polyester with supercritical CO2, but you cannot, with dispersed dyes, you cannot dye cotton with dispersed dyes. So currently, waterless dyeing doesn't really have an application for cotton dyeing.
That's great to hear. We had a couple of questions regarding that, so good insight on that. For Buddy, how would someone reduce the washing cycles of reactive dye cotton?
Well, one way is in using those higher fixation dyes that we had talked about earlier. The higher the fixation you have, the more dye that's covalently bonded to the cellulose fiber, the less dye you have to wash off. Also, if you're able to use dyes that will require less salt and less alkali, those components, those auxiliaries need to be washed out of that fabric. So in order to reduce the number of washes, you want to, one, be able to use less dye, less salt, and less alkali so that you're able to rinse faster. Also, the machinery has a lot to do with it. Well, how well does the machinery displace that water that contains that loose color into it as well? So in order to reduce that, you're looking at methods that will remove as much color, get it away from that fabric and down the drain, and have less color in the first place by using dyes which have a higher fixation rate.
Great. Another question here from the audience is any insight on print technology? Are there suitable technologies or sustainable dyeing print technologies available to talk about?
Yeah.
Well, I mean, in terms of print, I mean, there is digital print technology, but that within itself could be an entirely separate webinar. I mean, it's
Sure.
Yeah, it's a whole nother topic. But yes, there is quite a bit of technology in terms of digital printing. Now, a lot of times that's with patterns too, as well. I mean, I guess you can do blotch printing, but I don't know, Mary, you got anything to add to that?
Well, I mean, when we talk about printing cotton, I mean, typically, cotton can be printed with pigments or dyes. But to Buddy's point, digital printing has been growing and growing over the last 20 years and is available to print on cotton with pigments and with reactive dyes, and also is developed to print on other fabrics as well using pigments and, say, dispersed dyes or acid dyes. The benefits of digital printing are you don't have to make a screen, and then the amount of waste generated in digital printing is extremely low. Traditionally, if you're printing cotton with reactive dyes, you would pre-treat your cotton fabric with alkali and a anti-migrant, and then you can print on the fabric directly with the dye stuff. Dry it right on the machine, and you can go from one pattern to the next. You can print not only in like full width, you can also print pattern pieces so that you can take it right to the cutting machine and cut those pieces out And there's also direct to garment printing, which replaces the need for screen printing. And again, it's just like you're have a printer at your desk. You can print in unlimited colorways. Your pattern sizes are not limited, and you get instant design because no screens are necessary. So I agree with Buddy. I think there's an awful lot to be said about the different types of printing technologies that are out there, but absolutely, it is a sustainable approach to printing.
That sounds like a whole other webinar in itself that we'd love to explore. As you can imagine, our audience, we have brands and retailers, and they are working globally with businesses. And one question said, how available are these technologies in different parts of the world, or any insight, especially like in China or Vietnam?
Well, all of the technologies that we've talked about in this webinar are readily available. They're located in different locations, whether it's in Europe, North America, Asia. The origin of these technologies is all around the world, but they're available all over the world. So as Cotton Incorporated, we are a global company. We have a global outreach. So in that regard, we've talked about things that are available globally. A lot of the chemical companies, they can be sourced globally, as well as the machinery companies. So yes, they can. It's just a matter of making those contacts with these companies. I would dare say every company we've mentioned has a website and has support that you could find. You can make connections with them. So
great to hear. And then one of our last questions here is, again, either for Mary or Buddy, is what is the performance level of the Earth Colors dyes? Can you talk a little bit more about that?
Oh, the performance of the Earth Color dyes is going to match the performance of a traditional sulfur dye. So these are the Archroma Earth Colors are sulfur dyes. They're biosynthetic, so you're replacing some of the petroleum-based components of these dyes with natural materials, but the performance is equal to what you would see through their Dyrasol dye range.
Great. Well, thank you, Mary and Buddy, and thank you to the audience. That's all we have time for today, but we will be sure to reach out to any other questions that we get. And before you go, please ensure to take a moment to complete the survey. Your feedback is extremely important to us. Also, as a reminder, a replay of the webinar will be on Cottonworks and sent to your email. Thank you again to Mary and Buddy, and this webinar has now concluded. Have a great day.